All right, so last lesson you learned how to solve one-step equations that just had addition and subtraction. Today we're going to move beyond that and learn how to solve a multiplication equation as well. So before we get started, it's really important that we understand what inverse operations are. That's a big step in solving any equation. So I have a little warm-up for you. I would like you to, in each column, write the inverse operation of the number that you see in red. First, start with this column. Just tell me what's the inverse operation of subtraction, addition, multiplication, division. Then what's the inverse of -3 in the box, etc. So please pause the video, do that, and then you can check your answers. All right, if you are ready, here are the answers. So go ahead and take a look. And just check it out and remember that an inverse means opposite. Operation refers to subtraction, multiplication, etc. So just keep in mind and ask questions if you're not getting that still. All right, moving on. All right, today's goal, students will be able to determine the inverse or opposite operation for multiplication, and students will be able to solve algebraic equations where multiplying, or where x, or any variable, is multiplied by a constant. All right, today's strategy stretcher. Again, try this before the lesson. You're going to come back to it after the lesson and see if you can increase your strive for 5 score. So, show your strategy and solve. Bill bought 7 tickets to a basketball game for $21. How much did each ticket cost? Please do any strategy you can. If you can push yourself to do 2 right now, great. Otherwise, hopefully the lesson will give you some ideas. So pause the video, do that, and then you can go ahead and press play and keep going. All right, so what I want to do first is take a look at what's going on when we multiply. And I think that this reteach worksheet illustrates it really well. So in this case, a variable is going to be shown by a large rectangle, and each small square is going to be 1 unit. It says you can use tiles to help solve multiplication equations. Division undoes multiplication, so you can use division to solve multiplication equations. For example, to solve 3x equals 12, first use tiles to model the equation. So on one side of our balance, we have 3 x's. We don't know how much each x is worth, but we know that we have 3 of them. On the other side, we have 12 units. Now, we want to figure out what one of these x's is equal to. Remember, our goal is always to get the variable by itself. So we want 1x to remain on this side and figure out how many units that would be equal to. So next, divide each side of the equal sign into 3 equal groups. So the opposite of x times 3, or 3 groups of x, would be to divide that by 3, and that'll get us back to 1 group of x. So when we divide into groups, remember we could circle each group. That works nicely. So we circled our 3 groups, and then here's our 12 over here. Again, we have to keep the balance. So if we divide our 3 groups of x into 3, we need to divide our 12 units into 3 as well. And you notice when we do that, how many are in each of those groups. So each box of x goes with one of these groups, which is 4 units. So if we, again, divide 3 divided by 3, and we end up with 1, we divide this by 3, and we end up with 1. So you can see that x is going to be equal to 4. So the number of tiles in one group represents the solution. Again, here's our x. We divided the 3 x's by 3, which is 1x. We divided 12 units by 3, and 12 divided by 3 is equal to 4. So our goal was to get the variable by itself, which we did. We did the inverse of times 3, which was divide by 3. We kept the balance. We divided both sides by 3, and we're left with x is equal to 4. All right, we're going to move on and go ahead and do our notes. So if you will get your notes ready to go, please copy your heading, which is multiplication equations. And just a little side note, you don't need to write this, but a little side note, did you know that the fraction 3/4 also means 3 divided by 4? That fraction bar is also a division sign, and this is going to help us out today. Okay, remember too, our goal is to isolate the variable. We need to get x alone on one side of the equation. So here's our example today. 7x equals 63. So first step, we're going to use inverse operations. The opposite of x times 7 is to divide by 7. So the easiest way to show this is to just do a fraction bar instead of the division sign. It's really quick and easy. So divide by 7 and then divide by 7. We had to keep the balance. If I divide one side by 7, I must also divide the other side by 7 as well. So 7 divided by 7 is just going to be 1. Well, 1x is the same as x. So you can just cross this out, cancels out. And then over here we'll solve 63 divided by 7 equals 9. So you can see what we're left with. We have x over here. Our equal sign comes down, and 63 divided by 7 is equal to 9. And that's our answer. All right. All right, I'm going to come back to these problems, and I'm just going to go through some quick and just model for you how we're going to do this. So number one, we have 5x equals 15. The opposite of times 5 is divide by 5. So I'm going to just divide by 5. It's really important you show your work like this. It's quick, it's easy, and your success rate will be very high. So since I divide this side by 5, we're just going to do the same over here. Cross out your 5's because 5 divided by 5 is 1. And over here we're left with x equals 15 divided by 5, which is 3, and that's your answer. Right here we have 2x equals 6, and so we're going to divide by 2, divide then this side by 2. 2 divided by 2 cancels out. We're left with x equals 6 divided by 2, which is 3. Let's go back and check it really quick just to make sure that this is working. If x is equal to 3, then 2, if I substitute 3 for x, 2 times 3, does it equal 6? Yes, it does. So you can always check your answer by simply substituting your answer back in and seeing if it does make that expression or equation true. All right, number 3, the opposite of times 4 would be divide by 4. So keep the balance. This will cancel out. We're left with x. X equals 16 divided by 4, which is 4. And let's substitute and solve. Is 4 times 4 equal to 16? Yes, it is. Number 4, divide by 8. Divide by 8, keep the balance. Cancels out. We're left with x. 24 divided by 8 equals 3, so we have x equals 3. Substitute back in. 8 times 3 is 24. Go ahead and try the rest of these problems. Pause the video and then play to check your answers. All right, so make sure that you are ready for the answers because I'm going to show you those now. And then just take a second to correct it. Did you get the answers right? If not, take a look at the work that I showed and go back and fix it so that you get it. All right, moving on. We're going to play that equation dice game again. So if you have a partner to play with, that'd be great. What I'll do is I will roll the dice and then go ahead if you have a partner, see who can answer it first. And I'm going to give you about 8 seconds. So if you don't have a partner, just try to beat that 8 seconds. Here we go. 8t equals 48. I'll give you about 8 seconds. Go ahead and try to solve. And you should have gotten that t equals 6. All right, next problem. 12t equals 48. Go ahead. All right, you should have gotten t equals 4. And if you need more time than what I'm giving you, please feel free to pause the video and then start it. All right, next one. 3t equals 48. Go. All right, and you should have gotten t is equal to 16. Next problem. That one we had, so we'll try again. 6t equals 48. Go. All right, you should have gotten t, whoops, t equals 8. All right, I think we'll stop there and move on. I just want to show you the activity that you're going to do with a partner or by yourself today. Partner would be better. It's called the multiplication equation domino game. So make sure that you have all 16 dominoes. You should have a set of dominoes that look like this. So make sure you have those, you have all 16, and that they are cut out. Work together. See how fast you can put together the domino train by connecting each equation with its solution. Record the order to your domino train by writing down the answer portion of each domino in order on your paper, and then write the time in your packet. Just for fun, go ahead and try to time yourself and see how quickly you can do it. Don't be fooled. One answer will not have a matching equation. That'll be the first domino. We'll just have an answer with no equation before it. And then, of course, the last domino will have an equation, but not an answer. So there is one answer, one equation that does not have a match. So don't get fooled by that. All right, so you're going to go ahead and go on and do your activities and your practice problems for today. And then also, I would like you to, at this time, maybe before you do your activity, go back to your strategy structure. Can you add another strategy to this problem? So if you haven't already, try to have at least 2 strategies showing all your work. Make sure you have labels and try to get a little creativity into that for at least one of the strategies as well. So strive for 5, do your activity and your practice problems. Feel free to go back and look at the video again if you need more help. Good luck.